Hi guys, as I promised in our first lesson, that with this very lesson we are going to deal with questions and answers related to the first lesson I treated on set and operation. Okay, so with question 1 we have this question. So we have set U, set A, set B, and set C. So all these sets are written in set builder notation as a way of describing a set. So the question is, list the members of the sets U, A, B, and C, and then how many subsets can be found in set A, B, and C. Previous lesson we said that the universal set is the mother set of all the sets under consideration. The rest of the set becomes a subset. So in listing the members, we have 1 less than and equal to x. So because of the less than and equal to, we are going to start our count from 1. That is our starting member. And then with our ending member, we have x less than and equal to 12. Because of the less than and equal to, the underlying word here is the equal to, we are going to include the 12. So our count is going to be from 1 to 12. 1 to 12 because of the less than and equal to, because of the equal to underlined there. Okay, so let's move to set A. So with set A we have 2 less than and equal to x less than and equal to 5. So because of the equal to attaché the less than, we are going to start our count from 2 and then we are going to end at 5. So this is how it's going to be 2, 3, 4, 5. So let's move to set B. But when you come to set B, we have 5 less than x. So because of the less than, we are not going to start our count from 5. We are rather going to start our count from 4. And then we are going to end at 10 because of the less than and equal to 10. So it's going to be from 6, 7, 8, 9, and 10. And then when we move to the last set, which is the set C. So with the set C, we are going to start our count from 1 because of the 1 less than and equal to x. But we are going to end at 6 because we have just less than. So any number less than 7 is going to be 6. So we have x less than 7. So our count will start from 1 and then it will end at 6. Okay, so let's move to the second part of the question, which is how many subsets can be found in set A, B, and C. Okay, so with our previous lesson, we learned that in finding the number of subsets, we can use a rule or a formula, which is the 2 exponent n, where the n represents the number of elements in a set. Okay, so when we take the set A, how many members or elements do we have in a set A? We have 4 members, so the n becomes 4. So in finding the subset, we are going to replace 4 for the n. So we are going to get 2 exponent 4, giving us a 16 subset. So with set A, we can get 16 subset out of set A. Now when we move to set B we have 5 elements or 5 members. So with these 5 members, it represents the n. So in place of the n, we are going to put 5. So 2 exponent 5 is going to give us 32 subset. 32 subset. Okay, so let's move to the next set, which is set C. So with set C, we have 6 elements. So with 6 elements, in place of n, we are going to replace it with 6. So 2 exponent 6 is going to give us 64 subset. 64 subset. Okay, to the next question. Okay, so in solving the question, which is question 2, we have to tackle them one by one. We take the first set, which is set A, which is describing the set A to be factors of 12. So before we list the members of set A, we have to know what factors are. So factors are numbers that can divide exactly the number under consideration without any remainder. So the number under consideration here is 12. So what are some of the factors of 12, or the numbers that can divide 12 without any remainder? We know 1 can divide 12 times without remainder. 2 can divide 12 6 times without a remainder. 6 is also a factor because it divides 12 2 times, and then so is 3 and so is 4. So the factors of 12 are 1, 2, 3, 4, 6 and 12. Let's move to the next. So we have multiples of 3 less than 16. So before we list the members of P, we have to know what multiples are. So multiples of a number is the repeated addition of the number under consideration. So what is the number under consideration? 3 is the number under consideration. So repeated addition. So if I want to know the multiples of 3 less than 16, means that I take 3 and I add another 3, which is 6, and I add another 3, which is 9, and then add 3 to 9, which is 12, add 3 to 12, which is 15. And so these are the multiples of 3 less than 16. Move to the next. Odd numbers less than 20. Odd numbers less than 20. So you first have to know what odd numbers are before you can list your members. So odd numbers are numbers which cannot be divided by 2 to get whole numbers. So if you have any number, you divide by 2 and you don't get a whole number, it becomes an odd number. It becomes an odd number. We have a whole lot. If you want to know more, just get your books and learn. You get to know the rest. Okay, so what are these odd numbers which are less than 20? So now let's list the members. So we have 1, we have 3, we have 5. All these numbers, when you divide by 2, you are not going to get a whole number. So less than 20, so we end at 19. The next question, which is even numbers from 6 to 20. Even numbers from 6 to 20. What are even numbers? Even numbers are numbers which can be divided by 2 to get a whole number. Divided by 2 to get a whole number. So any number you take, when you divide by 2 to get a whole number, it is an even number. So our start or our count start will be from 6. So to find the set B or to list the members of set B, we have to start from 6. So from 6, then we have 8 up to 20, because the definition of the set was even numbers from 6 to 20. So numbers that can be divided by 2 are even numbers. We move to the next one. Prime numbers less than 18. Prime numbers less than 18. So what are prime numbers? Prime numbers or factors are numbers or factors which have no other factor except itself and 1. Except itself and 1. We are going to look for members for set C, which are prime numbers. So the definition of prime numbers we have already given. So we are going to look for numbers, and one thing you have to understand is that 1 is not a prime number. 1 is not a prime number. So which numbers are prime numbers? So we know 2 is a prime number because it can be divided by 2 and 1. 5 is also a prime number. You can only divide it by 5 and 1. 11 is also a prime number because you can divide it by 11 itself and 1. No other number can divide it except 11 itself and 1. So this makes it prime numbers. And then we have T, which is 1 less than or equal to X less than or equal to 8. So this we've done with the first question we did. So since we have the less than and equal to, we are going to start our count from 1 and then we are going to end at 8. Okay, so let's move to the next. So finally we have the last question, which is G. We have 3, 4 and then we have the dot before the 12 indicating they are missing members. So if they are missing members, then we just have to list the members. So we have from 5 to 11. You just fill them. So the next question. With our question, we are told to find P union Q. So in finding P union Q, we know that union means bringing two sets together. So we have P and Q. So finding P union Q means bringing the two sets together. And when you bring the two sets together, you are going to get 7, 9, 11, 12, and 13. Bringing the two sets together. Okay, we move to the next one. So the next one is intersection. So we are going to intersect P and Q. Most of the time when we speak of intersection, we are just talking about common terms or common elements or common members that are in both sets. So we have set P, we have 7, 11, and 13, set Q, 9, 12, and 13. So what is common? That is what I have highlighted in red. So 13 is common between the two, so their intersection will be 13. Now the next question is to find P prime. So we know P has a set 7, 11, and 13. So what is P prime? So P prime or complement of P becomes any other members that is in the universal set but is not in the P set. So with the P set, we know we have 7, 11, and 13. When you come to the universal set, any member which is not 7, 11, or 13 becomes P complement. So the rest of the members become P complement. And so it also applies to Q prime. So the next question is find Q prime or the complement of Q. So in finding Q prime, we go back to the universal set, and then we know that Q is 9, 12, and 13. So from the universal set, any other element which is not 9, 12, and 13 becomes Q prime. So the next we have finding the intersection between P prime and Q prime. So if you want to find the intersection between P prime and Q prime, it's all about finding their common members. So from P prime, what are the common members that can also be seen in Q prime? So from my highlighted red members, these are common. So we have 5, 6, 8, 10, and then 14 being the common members between P prime and Q prime. Okay, so it's been nice trying to do these tutorials for you guys, and I know that you guys have learned so much in this very video, and I'm hoping to do more. So take these few examples and try on your own. If you have any question, if you have any complaints, please try and list them below at the comment section, and then we'll try our possible best to bring you our next lesson, which is on Venn diagram of two sets. Venn diagram, handling two sets problem.